L'Hopital's rule. If f and g are differentiable functions with f of a and g of a equal to 0, then the limit as x approaches a of f of x over g of x equals f prime of a over g prime of a. So let's break down what this is saying. Let's say you have to evaluate a limit of a function where the numerator, the function's expressed as a ratio, and the numerator and denominator are both differentiable. So a reminder, we can calculate a derivative for them. That's important. So if we have functions that are differentiable in the numerator and denominator, and on our initial direct substitution to evaluate the limit, we get 0 over 0. That's what this part is saying. It's saying on evaluation of the limit, you got 0 over 0. We've already mentioned that that is an indeterminate form. Therefore, we have to do more work to determine what the value of the limit is. Before, we were using algebra and some cancellations and then a reevaluation to determine the limit. But what happens if we don't have the algebraic tools to simplify the equation? What we can do is utilize L'Hopital's rule. And what this says is you can take the derivative of the numerator and the derivative of the denominator and evaluate them wherever x is approaching in your limit. And that is how you alleviate the 0 over 0 problem. So what I want to make note of is that although the function in the limit is expressed as a ratio or as a quotient, L'Hopital's rule is not the quotient rule. All you're doing is taking the derivative of the numerator as an individual function and the derivative of the denominator, and you reevaluate. This process can be repeated as many times as necessary in order to get a determinant form. So if you take the derivative of the top and the bottom, you evaluate and you get 0 over 0 again, you can repeat this process as many times as you need to get a determinant form. So process can be repeated. So the process can be repeated until a determinant form is found. So let's look at some examples. Here's a limit that we asked you to memorize at the beginning of the year, but now we have the tool set to figure out what it should be using our derivative rules. So upon initial evaluation, sine of 0 is 0, x at 0 is 0. So I see 0 over 0, I can apply L'Hopital's rule to determine the limit. So this is going to now become the limit as x approaches 0, and I'm going to take the derivative of the top, which is cosine, the derivative of the bottom, which is 1. Reevaluate. Cosine of 0 is 1. Over 1 is 1. Next, initial evaluation. E to the 0 is 1. 3 times 0 is 0. Minus 1 is 0. 4 times 0 is 0. So I get 0 over 0. I'm now going to apply L'Hopital's rule. There's no factoring cancellations that can be done with that current format. So, derivative of the top, e to the 3t is e to the 3t times 3, right? There's a chain rule in there because of the composition. Derivative of 3t is 3, derivative of 1 is 0. So that's the derivative of the top. The derivative of the bottom is 8t. Reevaluation. E to the 0 is 1, 3 minus 3 is 0. 8 times 0 is 0. I got 0 over 0 again. I can repeat the process because the numerator and denominator are still differentiable functions. So I can calculate the derivatives of each one again. Up top, derivative of 3 times e to the 3t is going to be 3 times the derivative of e to the 3t, which we already found. So in total, we're going to get 9 e to the 3t. Derivative of 3 is 0. On the bottom, derivative of 8t is just 8. Evaluation at 0. E to the 0 is 1 times 9 is 9 over 8. So the limit is 9/8. So there's an example of applying L'Hopital's rule twice. C, sine of 3x over sine of 4x. You should see from here that you're going to get sine of 0 over sine of 0. Sine of 0 is 0, so you're going to get 0 over 0. So let's do the derivatives. We're going to apply L'Hopital's rule. Up top, we're going to get ultimately 3 cosine of 3x. And on the bottom, we're going to get 4 cosine of 4x. Remember, there's a chain rule there. That's where the 3 and 4 coefficients are coming from. Evaluate at 0. We're going to get 3 times cosine of 0, which is 3. We're going to get 4 times cosine of 0, which is 4. So 3/4 is the limit. Lastly, D, we have the limit as this function approaches 0. You should see that you're going to get 0 times e to the 0, which is 0, and then you're going to get 1 minus e to the 0, which is also 0. So we're going to have to calculate derivatives. Up top, you have a product, so be careful, right? Don't just do derivative of x times derivative of e to the x. Make sure you apply the product rule. All these derivative rules still apply when using L'Hopital's rule. So we're going to have left, d right, plus right, d left. And then on the bottom, derivative of 1 is 0, derivative of negative e to the x is negative e to the x. Now I can evaluate this at 0. This first term, x times e to the x, goes away. E to the 0 is 1 over. Negative e to the 0 is negative 1. So overall, the limit is negative 1. So that is L'Hopital's rule. Whenever you get that indeterminate form 0 over 0, to figure out what the limit is, you can take the derivative of the top and the derivative of the bottom and reevaluate, and that will give you what the limit should be.